Hello, welcome back. Today we are going to do lesson 2.2, graphing systems of inequalities, but we actually are going to split this up into 2 days. You will need your Springboard book, and the lesson starts on page 21. You will need a pen or pencil to jot down some notes, and then for tomorrow during your Zoom, you will need a graphing calculator, and you will probably want some graph paper if you have it to help you out. Okay. So first thing here, our learning targets are that we are going to represent constraints by equations or inequalities. And hopefully we know what a constraint is. A constraint is something that is going to put limits on your graph. Okay, like an inequality, we're going to see that. And then we will also use a graph to determine solutions of a system of inequalities. And that'll more so be in our next video. Okay. So looking at number 1 on page 21, it says Roy's spending money. So we're talking about Roy from the last video and the last lesson and how he was going to New York City and he wanted to go to different performances and eat different meals, and he had to pay for those. Okay. So Roy's spending money depends on both the number of tickets, T, and the number of meals, M. Determine which option is feasible for Roy and provide a rationale in the table below. So first of all, in case you're not sure what feasible means, go ahead and look over to the right here. And it means that something is possible or plausible in a given situation. Okay. And then also I gave you a little note right here to remember from the last lesson that tickets on average cost $100 and meals on average cost $40 in New York City. And that was what Roy researched. So we're kind of basing this off of what we did in the last lesson, but now we are putting both pieces together using inequalities. So first thing, I want you to kind of calculate and see what the total cost will be. And remember, his spending money that he had was $1,360. So that'll kind of tell you if it's feasible or not. Okay, so you're going to do some calculations, figure out the total cost, and tell me if it's feasible or not. So go ahead and pause the video to fill out the table. And hopefully you paused and you were able to fill this in. But if he bought 6 tickets and 16 meals, his total cost would be $1,240. So is that feasible? Yes. And the rationale there is because $1,240 is less than $1,360. Okay. Same idea with 8 tickets and 14 meals. That would cost exactly $1,360. So yes, he has enough money. But 10 tickets and 12 meals, that's $1,480. That's too expensive. So no, it's not feasible. And this last one was a little bit of a trick, but it should not be feasible because we are not going to buy a half of a ticket. So just keep that in mind, that is what makes it not feasible. Okay, cool. All right, then let's go ahead and move on here. And number 2 says, for all ordered pairs, TM, so that's tickets, meals, that are feasible options, explain why each statement below must be true. Okay, so A says all coordinates in the ordered pairs are integer values. So think about that for a second and explain why that must be true. Well, they must be integer values because both the meals and the tickets must be whole numbers or integers. Okay. And then B says if graphed in the coordinate plane, all ordered pairs would fall either in the first quadrant or on the positive M axis. So let's think about that. Remember where your first quadrant is. It's that upper right-hand corner. And we have to think about why that's true. And that is because both meals and tickets must be positive numbers. Okay, so we know we're not buying half of a ticket or half of a meal, and we know we're not buying negative meals or negative tickets. So that's why both of these must be true. Okay, cool. So then number 3 says, write a linear inequality that represents all ordered pairs, TM, that are feasible options for Roy. Okay, so this hopefully we've kind of been thinking about, but we know that, let's start with tickets because that comes first in the ordered pair. So we know that tickets on average are $100. So let's write that as $100 per ticket or 100T. Okay. Plus, we know that if he buys tickets and meals, that's why we're adding, but meals are $40 on average. So let's write that as 40M. And then we know that the total amount of money he has to spend is $1,360. And now what do I want to put there? Okay, do I want to put an equal sign, a less than, a greater than, less than or equal to, or greater than or equal to? And the correct answer here should be a less than or equal to. And here's why. Because the total amount that he spends on tickets and meals has to be either less than, or he wants it to be, less than his winnings or equal to his winnings. He does not want to go over that price. Okay? So that would be our linear inequality. Okay. Now, this next part, I want you to pause the video here. It says, if Roy buys exactly 2 meals each day, determine the total number of tickets that he could purchase in 5 days. So first of all, 2 meals, 5 days. So 10 would be what we are plugging in for M meals. And I want you to see the total number of tickets that he could possibly purchase. All right, so show all of your work and answer that question. And hopefully this is what you got. So again, I plugged in 10 for meals and I solved. I added 40 times 10 is 400. I subtracted that over. I divided by the 100 and I got approximately 9.6 tickets. But we know that we're not going to buy 0.6 of a ticket, and we can't round that up to 10 because if he buys 10, he'll go over the price. So he can purchase approximately 9 tickets. Cool. All right, same idea with number 5. Except now it says, if Roy buys exactly 1 ticket each day, find the maximum number of meals that he could eat in 5 days. Show your work. So now we're talking about 1 ticket each day, and there are 5 days. So 1 times 5 means we should be plugging in 5. But this time we're talking about tickets, so you should be plugging in 5 for T. And see how many meals he could then purchase. All right, so hopefully you paused the video and now you should be getting. So again, we plugged in 5 for tickets and 100 times 5 is 500. And then I subtracted the 500 over. I divided by 40 and I got 21.5. But again, we can't round up, so we know that he could purchase 21 meals while staying within his budget. All right, awesome. So that's our inequality and how we can use it to help us figure out how many meals or tickets Roy can buy. But now let's go ahead and graph, okay? So number 6 says, to see what the feasible options are, you can use a visual display of the values on a graph. Graph your inequality from item 3 on the grid below. Okay, so there are a couple ways you can graph here, okay? But again, we're graphing that inequality that we came up with on the last page in number 3, which is 100t plus 40m is less than or equal to 1360. Okay, and we're going to go ahead and graph that. And like I said, a couple of different methods here. You could rearrange it so that it's in y equals mx plus b form. You could use your cover-up method, and that is the method that I would recommend, okay? Because here's what we do. If you first cover up the 40m, you get 100t is less than or equal to 1360. Okay, when I do that, if I divide by 100 on both sides, I get that t is less than or equal to 13.6. And so that's what I would go ahead, I would place on the t axis right here. I would go ahead and place a point at 13.6, which I'm going to approximate to be right there. Okay, cool. Then I could do the same thing, but now I want to cover up the 100t. So I would do 40m is less than or equal to 1360. And then I would divide by 40 on each side. And I would get m is less than or equal to, let's see, 34. And then I would know, okay, I can place my point here at 34. And then all I have to do is, because this is a less than or equal to, I know it's going to be a solid line. Oops. And I'm just going to connect those 2 points. Okay. So that's what I mean by use the cover-up method. Okay. And it's just a little bit quicker, I think, sometimes. If you prefer getting it into that slope-intercept form, that is fine also. Okay. Now, because this is an inequality, and I know we just talked about why it's a solid line. So a less than or a greater than sign would be a dotted line or a dashed line. And with the equal sign underneath, that's what makes it a solid line. So that's why we created that solid line. Okay. But because it's an inequality, we also need to figure out which way to shade. Do we shade above or below? Okay. So what you want to do here is pick a point. And I'm just going to pick 0, 0 because that's easiest. Okay. So I'm picking this point here. And I'm going to test it. So I'm going to plug in 0, 0, okay, for my original inequality. Whoops. And when I do that, 100 times 0 is 0, and 40 times 0 is 0, right? So does this make the inequality true or false? Well, 0 is less than or equal to 1360. That is true. So I am going to shade towards the point that I picked. So this whole part would be shaded here. If that were false, then I would shade away from the point that I picked to test. Okay. Awesome. Here's another just quick picture. And ours looks spot on. Okay. All right. Up next here, it says, what is the boundary line of the graph? And that boundary line is actually just the inequality. But if we're talking about a line, it would be 100t plus 40m equals 1360. The boundary line they're asking about is just what separates it here. So that's the boundary line. Okay. And then this last part says which half plane is shaded and how did we decide? And the bottom half is shaded, or the lower half, and we decided that because we tested a point and it made the inequality true. So then we shaded towards that point 0, 0. Like I said, if it made the inequality false, we would shade away from the point. I would make sure you have that jotted down because that's an important piece of information. So pause the video if needed. All right, and last two that we're going to do today are parts D and E. Part D says, write your response for each item as a point in the form TM. Okay, so from item 4, if we go all the way back to item 4, it asked, okay, how many tickets, how many meals? Well, we have 9 tickets and 10 meals. So we would write that as 9, 10 as an ordered pair in the form TM, tickets, meals. Okay. Then if we go back to item 5, remember that we plugged in 5 tickets and 21 meals is what we got out. So we would write that as 5 tickets, 21 meals. Okay. And then the last part here says, are both those points in the shaded region of your graph? So let's go back and look. And the shaded region, so 9, 10 would fall about right here. And yes, that is in your shaded region or on our solid boundary line. So that works. And then 5, 21, that falls about here. So yes, that works as well. So we would say yes, both of those fall within the shaded region of our graph. And that's because they are solutions. We know that they are solutions. So that's why they fall within that shaded region. Okay. And if you plugged either one of those into the inequality, they would make it true, which is what we want. Okay. Cool. So tomorrow during the Zoom, we will talk about some graphing techniques for how to graph inequalities on your calculator. And that is it for day 1. Okay. If you have any questions, let me know. Thanks. Have a good one.